What is Pascal triangle? Pascal triangle is named after Blaise Pascal, a famous French mathematician and philosopher. It is one of the most interesting number patterns. Each number is the numbers directly above it added together. To build a triangle, start with 1 at the top, then continue placing numbers below it in a triangular pattern. The first diagonal is just ones. The next diagonal has the counting numbers 1, 2, and 3. The third diagonal has the triangular numbers. The fourth diagonal has the tetrahedral numbers. The triangle is also symmetrical. The numbers on the left side have identical matching numbers on the right side, like a mirror image.
The third example of Pascal's triangles pattern is exponents of 11. Each row represents the numbers in the powers of 11, carrying over the digit if it is not a single number. For example, the numbers in row 4 are 1, 4, 6, 4, and 1, and 11 raised to 4 is equal to 14,641. The numbers in row 5 are 1, 5, 10, 10, 5, and 1. Since 10 has 2 digits, you have to carry over, so you would get 161,051, which is equal to 11 raised to 5. The next example of patterns in Pascal's triangle is horizontal sums. Notice the pattern with horizontal sums. They double each time to the power of 2. 1 times 2 is equals to 2. 2 times 2 is equals to 4. 4 times 2 is equals to 8, and so on. The next example of patterns in Pascal's triangle is squares. For the second diagonal, the square of a number is equal to the sum of the numbers next to it and below both of those. So, you can see in the illustration that 4 raised to 2 is equals to 6 plus 10, which is beside of the 4 and below of them both. So 4 squared is equals to 6 plus 10, which is 16, and 16 equals 16. The next example in patterns of Pascal's triangle is odds and evens. If you color the odd and even numbers, you end up with a pattern the same as the Sierpinski triangle. So as you can see in the illustration, the Sierpinski triangle is almost symmetrical on the Pascal's triangle in terms of patterns.
Here are more examples of Pascal's triangle. The Fibonacci sequence. Make a pattern by going up and then along. Then add up the values as illustrated. You will get the Fibonacci sequence. The Fibonacci sequence starts with a 0 and a 1, and then continues by adding the two previous numbers. For example, 3 plus 5 is equals to 8. Then 5 plus 8 is equals to 13, etc. The next example is hockey stick pattern. You start with any number in Pascal's triangle and proceed down the diagonal. Then change the direction in that diagonal for the last number. That last number is the sum of every other number in the diagonal. Next pattern is Pascal's triangle, the primes. When you look at Pascal's triangle, find the prime numbers that are the first number in the row. That prime number is a divisor of every number in that row. Lastly, Pascal's triangle, triangular numbers. If you start with row 2 and start with 1, the diagonal contains the triangular numbers.
So we are here at the main code. The class name, public class Pascal. Of course, first we need to get how many lines the user wanted to enter. So system that print enter the number of Pascal triangle rows. And we use the scanner to get the user input. As we all know, we need to import first java.util.scanner for us to be able to use the scanner. And we will store it to the variable int no or number scanner.nextInt. Next, what we need to do is to run outer for loop to iterate through the number of lines. So here it is for int a equals 0, a less than no or number a plus plus. We will take it with 0 just to satisfy the formula to calculate the next number. As we look at the Pascal triangle, we will notice that it is exactly a triangle shape. So we need to be mindful for the spaces. And so we created a for loop to take care for the spaces. The logic will be the same. For int b equals 1, b less than equals spaces b plus plus. So here we are going to print the actual number now. First we need the variable which we need to initiate to 1. So here it is, int number equals 1. Because as we all know, the Pascal triangle starts with 1 and ends with 1. And we need to reinitialize it here. Otherwise, the number value will just be incremented and it will not be initialized to 1, so you will not get the appropriate values. This loop will be monitoring how many number of times you're printing the number. And this line is the formula for Pascal triangle. And after this, we need to decrement our spaces after each iteration of the number of lines and print new line. Let's see how our code works. So first, the code or the program has entered the number of Pascal triangle row. So let's try number 5. As you can see, Pascal triangle exactly looks like a triangle shape and starts with 1 and ends with 1. And as you can see, the spaces, and that's all.
Good day everyone. My name is Jhayson S and I'm here to discuss why we use GUI in our program. Why we use GUI is because designing the visual composition and temporal behavior of a GUI is an important part of a software application. In programming, in the area of human-computer interaction, ang goal nito is to enhance the efficiency and ease of use para sa mga underlying logical design na nakastart sa program, lalo na para mas mapadali ang paggamit ng mga users. So, the JPanel content pane. The JPanel is the simplest container class. It provides space in which an application can attach any other component. It inherits the JComponents class. It doesn't have a title bar. Next is the creating of the frame using JFrame. JFrame is a top-level container that provides a window on the screen. A frame is actually a base window on which other components rely, namely the menu bar, panels, labels, text, fields, buttons, etc. Almost every other swing application starts with the JFrame window. So, yan. Ito yung default close operation ng isa-set mo yung bounds and yung content pane. Yan yung layout niya, isa-set mo as none. Next is the J label. On the J label, in this part of the code, you can change or alter the background of your choice of the GUI. So dito pwede mo palitan yung title ng window at saka yung background. Yes. Next is the JText field. JText field, this is where the user input his or her desired value which the program will calculate. So, yun. Papakita ko mamaya kung yung actual na location nila. So, a J-scroll pane provides a scrollable view of a component when screen real estate is limited. Use a scroll pane to display a component that is large or one whose size can change dynamically. Other containers used to save screen space include split panes and tab panes. A JText area is a multi-line area that displays plain text. It is intended to be a lightweight component that provides source compatibility with the Java out. Next is the JButton. JButton class is used to create a label button that has platform-independent implementation. The application results in some actions when the button is pushed. It inherits abstract button class. On this program, we created three buttons. First, the calculate. The calculate button is used to make the program calculate for the desired number inputted by the user. Next is the reset button. For the reset button, it commands the program to reset to its original state. And for the quit button, it commands the program to terminate and exit the program. So, itong part na to, na-explain na to nung sa first code, nagkaroon lang ng minor modification since GUI tayo. So, ang mangyayari sa append is yan na yung printing natin, tapos magpiprint siya sa text area ng result. Next, the J level. In this part of the code, you can change or alter the background of your choice of the GUI and the title of your window. So, ito. Ito yung J level na sinasabi ko kanina, yung background niya, tsaka yung title, plus yung text field. Dito magta-type yung user kung ano yung desired niyang number. And then, next, ito yung tatlong button, the calculate, reset, and quit, na pipindot niya ng user kung anong gusto niyang gawin dun sa in-input niya. Next is the J scroll pane. Ito yung pwede mo siya i-scroll. And then next is the JText area. Dito lumalabas yung output ng JText field at kung anong pinili mong operation. Kung calculate ba, reset, or quit. That's all. Thank you.
So good day to everyone. Here is the presentation of our groups code for the input and output of our project. So the algorithm used for this code is called recursions, and recursion is basically a method which calls itself continuously until it reaches a base case. So in this case, our group used GUI to make the program to be a more user-friendly platform. So let's just wait. And for the input, you just need to enter the number of lines of your choice, and you need to click calculate for the output to be displayed. You can also reset the displayed output for you to be able to input a new number of lines. So in this example, Scott Glenn Jimenez will input some numbers, and the program or method will only be completed when it reaches the base case, which is the number we have inputted. So first is number 3. As you can see, he clicked on reset, so we can input a new number to be calculated. Next is 5, then 15, we're gonna skip a bit. Next is 30. The next is 25. 10. 12. And that is all.